At Ciba Geigy, research scientists create products which enrich the quality of our lives. Products to increase our food supply, dyes and pigments which surround us with color, pharmaceuticals to improve our health, products which reaffirm the value of science to mankind. As part of its continuing program in support of science education, Ciba Geigy is pleased to present this issue of the Science Screen Report.
The Science Screen Report, developments in science, engineering, and medicine that help solve the problems of modern life. The oceans, covering 70% of the Earth, collect and store solar energy, an immense reserve of potential power. Today, scientists and engineers are developing advanced technology to extract this heat and convert it to electricity. Ocean Thermal Energy Conversion, OTEC. In the near future, such OTEC power plants would provide pollutionless, almost unlimited supplies of energy. This is a report on progress towards harnessing the ocean's energy resources. The oceans of the world are storehouses of enormous amounts of solar energy. A century ago, the French scientist Arsène d'Arsonval proposed using the temperature gradient between the sun-heated surface waters and the cold deep to produce electric power. He suggested warm surface waters could vaporize ammonia as at right, driving a turbine to make electricity. Cold, deep water in the condenser at left cools the ammonia to liquid, and the cycle is repeated. Part of the electricity drives the water pumps. The surplus is available for any purpose. In the late 1970s, the first ocean thermal energy conversion system, mini OTEC, was built and installed aboard a barge, moored 3 kilometers off Hawaii. After beachfront assembly of the kilometer-long deep water pipe, also used as a single-point mooring, the pipe was towed out to the waiting ocean heat power plant barge. Cold water pipe and barge are linked and activated. The hot surface water, piped into the evaporator, heats ammonia, which drives a turbo generator to produce electricity. Then passes through a condenser where cold bottom water cools it to liquid again, and the process is repeated. For 3 months, Mini OTEC's generator, powered only by the temperature gradient, 27 degrees centigrade on the surface, 4 degrees centigrade in the deep, produces 57 kilowatts of power. 40 kilowatts drive the pumps and other OTEC machinery. The surplus 17 power onboard instruments. Mini OTEC demonstrates the OTEC principle, a reliable ocean energy power source. In the early 1980s, the next step, an oil tanker is refitted as a full-scale floating OTEC laboratory and renamed the SS Ocean Energy Converter. The test site chosen for the project, OTEC 1, is 19 kilometers off Hawaii. To anchor the ship, a 4,000-foot single-point mooring is deployed, shown here with stop-motion photography. Meanwhile, on a windswept Hawaiian beach, the cold water pipe is assembled. Its triple cluster of 1.3-meter diameter, buoyant, flexible polyethylene pipes is 670 meters long, almost half a mile. A 50-ton buoyancy collar enables the pipe to stand vertically when released from the ship. The pipe, which can deliver up to 78,000 gallons of water per minute, is assembled on railroad carriages. Stop-motion photography shows deployment of the deep water pipe, the million-pound conduit extending across the entire bay. The pipe is then towed by tugboats to the OTEC 1 mooring and ship. During delivery, the flotation collar keeps the high front end afloat. While the deep tail end is supported by a barge. Arriving at the mooring, the pipe is stretched across the surface of the sea. Then slowly back down into the deep. A 75-ton weight keeps it vertical as it goes down. Once in position, divers check the pipe's flotation collar and align underwater TV monitors and its stabilizing system for link-up with the ship. Mating to the ship is critical. The stabilizing system and flotation collar, which link ship and pipe, must be made to function effectively. The stabilizer system minimizes the effects of pipe motions due to deep-sea currents. The flotation collar allows the pipe to float, aiding recovery should bad weather force the laboratory vessel to return to port. The SS Ocean Energy Converter carries full-sized heat exchangers, condensers, evaporators, and pumps, and could, in principle, generate a megawatt of electrical power. Unlike many OTEC, however, it lacks turboelectric generators. Rather, its purpose is to gather critical engineering performance data. It is a floating OTEC laboratory, probing problems that must be solved before full-scale commercial OTEC plants can be built. What are the best designs for pipes and heat exchangers? How might marine life and corrosion affect OTEC systems? What are the impacts of OTEC on the ocean environment? How can the efficiency of evaporators and condensers be increased? In time, the components and concepts field tested aboard OTEC-1 could be employed in 40 to 80 megawatt demonstration OTEC power plants, which would produce usable power. OTEC could also power offshore smelters or refineries or chemical plants, electrolyzing seawater to make hydrogen, liquefacting air to make nitrogen, combining hydrogen and nitrogen to make ammonia to be processed into fertilizer. Energy from the oceans might also be extracted utilizing underwater windmills powered by ocean currents. Or ocean wave energy tapped using dam atolls, which divert waves into an inverted bowl-shaped collector spinning a turbine. A proposed tidal energy extraction system employs rising waves to compress air to spin turbines, and falling waves to draw in air to maintain the spin. A reshaped seabed could funnel waves, focusing their energy to spin turbines directly. Still other ways to draw on the ocean's various energy potentials: currents, waves, tides, ocean heat, sea and land winds, salinity gradients, and others are being sought. The first OTEC power plants will probably be sited near major islands, such as Puerto Rico or Hawaii, which currently use about 600,000 barrels of imported oil per day. Other near-future OTEC locations include Guam, French Polynesia, Singapore, and Rio de Janeiro, as well as Florida and other coastal states. Ocean surface temperature profiles suggest the best OTEC locations, tinted red or orange, are about 20 degrees latitude from the equator. The Gulf of Mexico coastline alone might generate as much as 50,000 megawatts of power in a few decades. OTEC, Ocean Thermal Energy Conversion, an energy source which is continuous, pollutionless, almost unlimited, and requires no new technical breakthroughs. OTEC, solar energy from the sea to benefit everyone. Another way of turning the sun's power into useful energy.
Science Screen Report has been produced by Ciba Geigy Corporation, with headquarters in Ardsley, New York, as part of its continuing program in support of science education.